Okay, welcome to this Friday, April 3rd edition of Kitchen Table Chemistry. And what we're going to be doing today is taking a look at Charles's law. Charles's law is a gas law, and it is the relationship between the volume and the absolute temperature of a gas. So in Charles' law here, we're going to be looking at volume and temperature, not looking at pressure. This is going to be a direct relationship. And the volume of a gas is going to be related to the absolute temperature or the amount of energy, which is what temperature is of the gas. So the more energy the gas has, the greater the volume it's going to hold. And if you think about it, the more you heat up a gas, the more it wants to expand. And that's really what we're talking about here. In order for Charles' law to work, we have to use Kelvin temperature. Kelvin temperature is the absolute temperature. 0 Kelvin, 0K is absolute zero. It is the lowest energy state possible, and at absolute zero, all molecular motion ceases. It's kind of an interesting concept. It's never actually been done in a lab, but if you want to take a look on that, you can find some interesting information on it. The advantage of using Kelvin is it has no negative numbers. When you want to convert into Kelvin, the formula is pretty straightforward. Just take 273 and add the degrees Celsius to it. So say a 30 degrees situation would be 303 Kelvin. So Kelvin is equal to 273 plus 30, 303. That's the math of it right there. If it was negative 30, you'll be subtracting that and ended up with 243 Kelvin. But we have to always work in Kelvin, work in that absolute value. Oh, hey, come on back. Working at absolute value. Cannot work in Fahrenheit ever. No Fahrenheit ever. Okay, Charles' law. You might want to put this on the back of your periodic table to remember it. Is V1 T2 is equal to V2 T1, where the initial volume times the final temperature is equal to the final volume times the initial temperature. It's a direct relationship, and I made a little tiny sketch of it there. You can also do Charles' law as V1 over T1 is equal to V2 over T2, and that it will look like that if that's how you solve things better mathematically. I have found most students will use it the way it's written at the top there, V1 T2 equals V2 T1. The direct line, the interesting thing about this relationship is it will, right down here, will be absolute zero at the lowest possible. And that 0 degrees Kelvin should get you no volume at all from your gas. Okay, when can we use Charles' law? Charles' law is useful when pressure is constant and the amount of gas in moles is constant. So we have to have a constant pressure. We can't be, changing it at all. So atmospheric pressure, Charles' law things tend to take place at atmospheric pressure. And the amount of gas can't change. We can't be adding or subtracting the amount of gas that we're putting in there. A hot air balloon will be a classic example of how this works. Hot air balloons work on the principle of heating the air up. When you heat the air up, the volume increases, and as the volume increases, the density decreases, and that's why they actually float. The hot air inside is less dense than the surrounding air, and therefore the balloon becomes buoyant and is able to float. As long as you can heat the air up inside the balloon, I think as soon as you can stop heating the air up inside the balloon, the whole thing is over. But that's why they work, and that the principle of increasing the volume of the air through increasing its temperature and therefore decreasing the density of the air. Okay, now I'm going to show you a practice problem here. This practice problem, what we have here is an initial volume of 5.0 liters and an initial temperature of 30 degrees Celsius. This 30 degrees Celsius would be 303 Kelvin, is equal to V2. V2 is the X that we're going to try and find here, so our X value. And then T2 is the warmer 80 degrees Celsius, which will be 353 Kelvin. So my formula, V1 T2 equals V2 T1. Initial volume is 5.0 liters times T2, which is 353 Kelvin, is equal to V2, which I don't know, times T1, which is 303 Kelvin. Then I set it up to solve for V2, and I have 5.0 liters times 353 Kelvin. Dividing that all now by the 303 Kelvin, this is how the kelvins will cross out. The only unit left is the liters, and V2 will end up equaling, I'll turn my calculator on here, about 5.7 liters in size. And again, I'm just going to go to one decimal place because that's what was in the question. So this is how you solve Charles Law questions. They're fairly basic like this. I've included a few in today's assignment to take a look at. Should take you just very few minutes at all. We'll be adding this in Boyle's Law and then a third law called Gay-Lussac's Law, and we'll take a look at that on Monday. I also included some information in today's assignment or today's announcement about an extra credit opportunity if you are interested, and that is available to you. I hope you have a great weekend and that you are safe wherever you are at home. And if you are considered an essential employee, please, my heart goes out to you. I hope you are doing okay and that people are treating you well and that you are safe wherever it is that you are working. This is everything for Friday. I will talk to you again on Monday and have a great weekend. Bye-bye.